Hi, my name is Mel Sobel, and I am a civil engineer at San Diego State University. And today I'm going to be talking about how to solve for the principal stresses and the max shear stress. So here I have drawn out the diagram, and we have three cylinders with three forces acting on it, and these are the lengths given to us, and these are the forces given to us. So the first step in solving this problem is to solve for the torsion, and as you can see, there's a torsion acting on Py in the ZY plane. So the first step is to find the resultant torsion, which is adding the Py torsion and the Pz torsion. So the Py times 10 right here, because it's acting there, and it's causing the cylinder to rotate. And your answer is 1,750 pounds per inches, and the torsion in the z plane, in the yz plane, which is pz times d, 125 times 8, which is equal to 1,000, but this is actually going to be negative because it's turning in the clockwise direction, and the Py is acting in the counterclockwise direction. To find the resultant torsion, we have to add both the values, and your resultant torsion is 750 pounds per inches. So we're going to write that off to the side because we're going to need it later on when trying to find the principal stresses per inches. Okay, so now we got to find the resultant moment, and we're going to find them in the x, y, and the z. So moment in the y direction is going to be 175 times 12, because right here, and it's right at the point of H, and the answer is 2,100. And now we're going to find the moment in the x direction because they're both on the same plane. And for this one, it's going to be 100 times 8, which is equal to 800 pounds per inches. Okay, and now we're going to find the moment in the z direction, which is going to be 18 times 125. And the answer for that is 2,250 pounds per inches. So now to find the resultant momentum, we have to do 2,900 squared plus 2,250 squared. And your answer for that is 3,670.5. We're going to write that off to the side because we're also going to need that later on to solve for the principal stresses. Okay, so I'm going to go ahead and erase that. Okay, so now the next step is to solve the polar modulus and the section modulus, which the equation is right here. And I'm just going to write out the answer for that just because it's pretty self-explanatory. So polar modulus is equal to, let me do this really quick, 0.663. The sectional modulus is equal to, so the diameter is 1.5 cubed times pi divided by 32.33. And we're also going to need the area, which is just pi over 4 and the diameter squared times pi divided by 4. Your answer is 1.77. Okay, and now the final step is to solve for the bending and the axial stresses and the shear stress. So the shear stress is, we take the resultant torsion divided by the polar modulus, and the shear stress will equal 750 divided by 0.663, 1,131. And now for the bending, you take the resultant moment and you divide it by the section modulus. And the answer for that is 1,182. And now for the axial, it's just the force in the x direction divided by the area. And your answer for that is 56.6 psi. Okay, now that we have all the values, now we can plug it all in to this equation. And once you solve for it, you get divided by 2, 5,000. 0.3 plus or minus plus the shear stress squared, and you get negative 1,114 by 11 KSI. This is in PSI. So this is your principal stresses. Let me write that out. So this is for your first one. Now the max shear stress is just and the answer for that is 5,683.32 psi. Thank you.